ASCII is useful for representing basic text, but it has an important limitation. Original ASCII uses 7 bits. 7 bits provide 2 to the power of 7, which gives us 128 possible codes. Later, 8-bit character sets increase this number. With 8 bits, we get 2 to the power of 8, or 256 possible codes. That gives us more characters, but it is still not enough. Around the world, people use many different languages, with thousands of different letters, characters, and symbols. So even 256 codes cannot represent everything we need. This is why computers needed a much larger character standard, and that leads us to Unicode. Computers are used all around the world by people who speak and write many different languages. We have English, Sinhala, Tamil, Chinese, Japanese, Korean, Arabic, and Russian. Each of these languages uses its own characters and writing system, so a computer cannot support only basic English letters and symbols. Modern computers need a way to represent many different writing systems from around the world. This is one of the main reasons why a universal character standard, such as Unicode, is so important. An 8-bit character set gives us 256 possible codes. At first, that may sound like a large number, but when we think about all the characters used around the world, 256 is actually very small. We need codes for English characters, Arabic, Chinese, Japanese, and Korean. And that is not all. Computers also need to represent mathematical symbols, currency signs, and many other special symbols. Trying to fit all of these into only 256 codes simply does not work. The world needs far more than 256 character codes. So we need a much larger character standard, and that is where Unicode becomes important. When computers communicate, they need to agree on what each character code represents. For example, the sender wants to send the letter A. The character A can be represented by the decimal value 65. That code travels across the network to another computer. But if the receiving computer interprets the code using a different character standard, it may display the wrong character. This creates a problem. Now look at the second example. Both computers use the same common standard. The sender sends the code for A, and the receiver interprets it correctly as A. So the important idea is simple. For text communication to work correctly, both systems must agree on what each character code represents. This is why having a common character standard, such as Unicode, is so important. Now, let's understand what Unicode is. Unicode is a universal character standard. It was created so computers can represent characters from many different languages, using one common system. Unicode supports Latin characters, Sinhala, Tamil, Chinese, Japanese, Korean, Arabic, Russian, and many more. But Unicode is not only for letters. It also includes currency symbols, mathematical symbols, special symbols, and emoji. Each encoded character is given a unique identifier. For example, the letter A is identified as U+0041. The computer can then represent that character as digital data. So the key idea is, Unicode gives computers a common way to represent characters from around the world. Unicode is designed to support writing systems from around the world. For example, we can write hello in English. We can represent text in Sinhala. Chinese characters such as ni hao. Japanese characters, Korean characters, and Arabic characters. These writing systems may look very different from each other, but Unicode provides a common standard for representing their characters. This means computers do not need a completely separate character system for every language. Instead, Unicode provides a very large collection of characters, with defined codes that computer systems can recognize. So the important idea to remember is, one Unicode standard can support characters from many different writing systems around the world. Unicode is not only used for letters or different languages. It can represent many other types of characters as well. For example, Unicode includes punctuation marks, such as exclamation marks and question marks. It also includes currency symbols, like the euro, pound, and yen. For mathematics, Unicode can represent symbols such as the square root, infinity, and plus or minus. It also supports special symbols, such as copyright, registered trademark, and trademark symbols. And in modern communication, Unicode also includes many emoji. So remember, Unicode represents much more than alphabetic characters. It provides a common standard for letters, punctuation, symbols, mathematics, currencies, and emoji. Unicode is also important for representing mathematical and specialist symbols. Think about a mathematics document. It may contain symbols such as plus or minus, multiplication, division, square root, infinity, and comparison symbols. Just like letters, each of these symbols needs an agreed numerical code. Unicode provides these codes. The same idea applies to specialist and currency symbols. For example, the copyright symbol, the registered trademark symbol, the trademark symbol, and currencies such as the euro, pound, and yen. By assigning agreed codes to these symbols, computer systems can store, display, and exchange them correctly. So the key point is, symbols need agreed numerical representations, just like letters do. Unicode is also used to represent emoji. For example, a smiling face, a heart, a thumbs up, a globe, or a car. Each emoji has a defined Unicode value. This means different devices can recognize the same underlying character. For example, the same smiling emoji can be sent from an Android phone, viewed on an iPhone, and displayed on a computer. But you may notice something interesting. The emoji can look slightly different on each device. That is because different platforms may use their own visual design. However, the underlying Unicode character remains the same. So remember, the character can be the same, even when its appearance differs. Now let's understand what a Unicode code point is. A Unicode code point is a unique numerical identifier given to an encoded character. For example, look at the uppercase letter A. In Unicode, the letter A has the code point U plus 0041. Unicode code points are commonly written using U plus, followed by hexadecimal digits. Hexadecimal uses the digits 0 to 9 and the letters A to F. So when we see U plus 0041, we know that this value identifies the character A. The important idea is simple. A code point tells us which character it is. Later, an encoding method determines how that code point is actually stored as bytes in the computer.